Here's problem P58 from the book. It says a particular Alnico aluminum, cobalt, nickel, and iron bar magnet A has a mass of 10 grams. It produces a magnetic field of 6 times 10 to the minus 5 Tesla at a location 0.19 meters away from the center of the magnet. So we might have something like the bar magnet in the center. This is 10 grams. And then we pick a point here that is 0.19 meters away. And we're on the axis of the magnet. And it says approximately what is the magnitude of the magnetic field of magnet A at distance 0.38 meters from the center of the magnet along the same axis. So 0.38 meters is twice the distance. So we would say R goes to 2R. And we know for these magnets we can write the magnetic field as mu naught over 4 pi 2 times the magnetic dipole moment over R cubed. And so the magnetic dipole moment is a constant for 10 grams worth of the material. And then mu naught over 4 pi is a constant, and so all we're doing is changing the R value. And so if we consider B1 is equal to mu naught over 4 pi 2 mu over R1 cubed, the ratio of that to mu naught over 4 pi 2 mu over R2 cubed. That should be constant because we know that the magnetic field is going to change according to those functions, and so the magnetic field B1 to B2, everything here will cancel that is constant, so let me just mark those. And so that means that we're left with 1 over R1 cubed over 1 over R2 cubed. But that will just be R2 cubed over R1 cubed. And that's equal to, in this case, R2 is twice as big, so we have 2R1 over R1, sorry, that's cubed. And so that will end up being 2 cubed, R1 cubed over R1 cubed. So that means that B1 is 8 times bigger than B2. And so if it were 6 times 10 to the minus 5 Tesla, then we could write this, and so that would be .75 times 10 to the minus 5, or 7.5 times 10 to the minus 6 Tesla. Part B asks, if you remove the original magnet and replace it with a magnet made of the same material but with a mass of 50 grams, magnet B, approximately what would be the magnetic field at a location 0.19 meters from the center of the magnet on the axis of the magnet? Well, you can think of a magnet as just being made up of loops of wire that create the magnetic field. And of course we know that these fields loop around like this. But if 10 grams of magnetic material corresponds to some number of equivalent loops of current, then if we go from 10 grams to 50 grams, it's as if we've increased the amount of loops by a factor of 5. So that's equivalent to saying that mu goes to 5 mu because we have 5 times the number of loops. And so we would expect that the magnetic field would go up by a factor of 5 as well.